With logarithms, there are various laws that can be used to help solve logarithmic equations. These laws involve the ability to expand or condense the logarithms as needed. So when you get to solving logarithmic equations, sometimes you need to expand or condense them depending on the situation given. So the first one we have for the laws is the product rule for logarithms. It just states that if you have m, n, and b being positive real numbers and b is not equal to 1, then log base b of m times n is going to be log base b of m plus log base b of n. The multiplication inside the parentheses, inside the argument, becomes addition on the outside. And conversely, if you have two logs of the exact same base adding, you can bring them back together as multiplication. Same thing goes for natural log. ln of m times n will be ln of m plus ln of n. Again, the multiplication on the inside becomes addition when expanding it. And if we have two ln's that are adding each other, we can take their arguments m and n and just multiply them back together. So it seems a little bit weird, but much easier to see in practice. So let's start with the first one. We're going to take log base 5 of 25x, and we're going to expand it. In here, I see that 25 and x are multiplying. So essentially here, 25 is m, and x is n. So we can just separate it like that. So when we do that, we're going to have log base 5, because everything is log base 5 here for this expression, of 25 plus log base 5 of x. We took what's inside the argument and separated it out into two. Now this is good enough as an answer, but if you want to be a little bit more bold, you could even take 25 and say it's 5 squared plus log base 5 of x. And then you can reduce log base 5 of 5 squared to just 2 using properties of logs plus log base 5 of x. So these are all the same thing. You can stop here technically because we've expanded it, but if you want to go that extra mile, you can do this down here. So whichever you prefer. Next we have ln of x ln of x times e, And so here x and e are multiplying. So just like with before, I have my x, which is the m, and e, which is the n. So when I separate it, I'll have ln x plus ln e. So when I do that, I'm going to get ln x plus ln e, because everything gets an ln, separated by an addition sign. And this is a good way to end it, but if again you are just going to take it that one extra step, we know that ln e, using properties of natural logs, is just equal to 1. And so both are the same answer, but if you want to go one more step further, that's what you would do. Now let's go the other way. Let's condense the logarithms. So log base 3 of x plus log base 3 of y. Both are log base 3, so the exact same. If they're not the same, you can't condense them. And they're separated by an addition sign. So we're going to take x and y and bring it back together as one logarithm. So 1 log base 3 times xy. They are brought back to a multiplication. So there's my answer as a single logarithm. Now I'm going to do it one more time. I got ln 12 plus ln of x plus 1. Both are ln's, separated by addition. So because it's addition, I'm going to bring them back together as multiplication. So ln of 12 times x plus 1. And that's a good way to end it here, but again, let's take it one step further. I'm going to distribute the 12 inside, and I'm going to get ln of 12x plus 12. And here is my condensed logarithm for this rule.